Today we are going to see about the equivalent circuit of transformer. The electrical circuit for any electrical engineering device can be drawn. Its equation describing behavior of no. The equivalent circuit of electromagnetic device is a combination of resistance, inductance, capacitance, voltage, etc. So, so the current in IM is represented by the resistor reactance X0 and is called magnetizing reactance. And the transformer magnetizing curve is assumed linear since the effect of high order hormones can be represented by the equivalent circuit. In transformer analysis, it is useful to transfer the secondary quantities to primary side or primary quantities to secondary side. This is the diagram for the exciting current negated. Here R1 extends the primary parameters, X2, R2 is the secondary parameters. This is the exact equivalent circuit of transformer. The transformer loss of primary and secondary copper losses, iron losses, dielectric losses and stray load losses. The primary and secondary copper losses takes place in their respective winding resistance due to the flow of current in them. The primary and secondary resistance differ from their DC value due to skin effect and the temperature rises of windings. While the average temperature rise can be approximately used, the skin effect is harder to get analytically. The short circuit test gives the value of RE taking into account skin effect. The iron losses contain two components, hysteresis losses and eddy current losses. The hysteresis losses is a function of material used of the core for the constant voltage and constant frequency operation. That can be taken the constant. The eddy current losses in the core arises because the induced EMF in the steel lamination sheet and the eddy current formed to it. So, whether T is the thickness of the steel lamination used. The dielectric losses takes place in the insulation of transformer due to the large electric stresses. In case of low voltage transformer, this can be neglected. For constant voltage operation, this can be assumed to be constant. This leakage flux link in the metallic structural parts, tank, etc. produce the eddy current losses in them. So also the leakage flux is directly proportional to the load current, the mutual flux which is proportional to the applied voltage. Hence this loss is called stray load losses. It can be modeled by another resistance in the series branch in the equivalent circuits.